So can you walk us through how to optimize buildings for passive heating and cooling features? We would also like to know how succinct numbers may be generated and stimulated to include in the design.
Passive design features, definitely there is with the help of simulation software, like Abhishek was mentioning about his presentation. So we can do a lot of optimization in that. Like during the design phase, when your concept is prepared, your conceptual design is happening, you can do the passive design features to do those kind of analysis, like microclimatic analysis. Either you know the sun path analysis can happen. Accordingly, we can talk on daylighting part, how your natural light came inside without doing anything, that those kind of analysis if you do. And third thing, what the cooling technologies, because we do energy simulation. So in the energy simulation, where are the chances, we need to understand what kind of the wall, roof, or the entire building envelope we are constructing. So how the heat will transfer from outside to the inside. If our passive design features, if we are putting a overhang, fins, definitely the heat will get reduced. So accordingly, we can have less air conditioning design. So initial optimization is very much required. In the green building certification, the ECBC is the mandatory thing to do. And in the ECBC, these all analysis is required to do that. So yes, this is kind of a software understanding is required when we do the passive designing. If you do want to see the outcome of it, if you are an experienced an architect, you can do the passive design feature. But you want to change some outcome, you want to see the result, you can do the help with the help of simulation software. It is possible to do.
Wanted to add one point that all
Yeah.
of the simulation tools which you mentioned, they help to quantify the performance of the desired metric which is being evaluated right at the early design stage. So which ensures that the value engineering happens right from the day those design decisions are taken, and not a retrofit which happens post execution or post passing its stage. So having an analytical tool to quantify daylighting performance or energy performance or any other performance actually helps the design to become more optimized.
Okay, thank you, Abhishek, for your insights as well. So my next question is to Kritika. So when we speak about green building, so we always think about green buildings as energy efficient buildings. So in this context, how do you think it is important to prioritize the recovery of rejected energy, wasted energy, especially for commercial structures, and this pave way to decarbonizing buildings?
Okay, interesting question. The wasted energy right now, I feel, is very hard to quantify. So we have to first look at knowing how much of energy that is it that we are actually wasting before we look into then recovering it, reclaiming it, and reusing it and all that. Like Akshay was talking, unless we know what is happening, if we don't measure what is happening, then there is no way we are going to be able to overcome that. That said, once we do have an idea of how much of energy is getting wasted, then a lot of technological interventions are required to recover that wasted energy. So, for the first thing is to you try not to waste it in the first place, try to use it as much as possible. But then, if it does get wasted, like let us say the heat that is going out of your air conditioning system, which is also wasted energy, or from your diesel generating systems, so much of energy gets wasted every day in a building. So then how do we recover that? Is something that requires a lot of research, which I feel is sadly lacking right now. There's not many people who are into that. There are some waste to energy recovery systems and all that, but they are on a very superficial level, and right now I feel that they're not making much of an impact, and a lot of progress is required in that area for this to actually contribute towards decarbonizing the building as such. But I do welcome other opinions on this as well.
Yeah, I would also want, if anybody else has another opinion, please share.
I would just like to add that, here, like you mentioned it right, Kritika, the choice of technology early on, when the MEP systems are getting designed, it really makes a lot of difference. If I have to give an example, if let's say we are looking at a hotel building that is being built, and there is a requirement for the hot water systems. So there are definitely the various different options available. We could look at a boiler or a hot water generator. But there are other technologies like heat pump, which is very, very efficient, which uses less energy to deliver the same outcome, and is considered by far very sustainable. And it is mostly used in the Western countries also. But in Indian context, the adaptation of such technology which are already evolved is less because of the high initial investment that is attached to that concept of heat pump. Although many energy efficient hotels claim to have installed and have been using these technologies, but we cannot yet say that these things are mainstream. So and for that, a little bit of shift in the mindset in context of these evolving expectations would really make a big difference.
So I always say, I think the Akshay has mentioned about it for the new technologies, but I always say waste is a wealth. Whatever the wastage you are doing from the building, it is a wealth, and you can reuse that somehow. So because I'm an expert in energy efficiency, I do a lot of, also a vice president for Society for ISRE. So in ISRE, when we talk about the energy efficiency, majorly goes in commercial building for air conditioning. Because 65% to 70% energy in any existing building, if you calculate, is related to the HVAC. And HVAC plays a very important role. So there are the chances to do the innovation, whatever the waste you are doing, like 1 kW of, when we run the air conditioning system, around 3.5 kilowatt of heat, 1 ton air conditioning emitting in the environment. And there should be a technologies where we can extract that heat. Already, like Akshay mentioned about heat pump, these are the technologies where we can see in the hotel, in the hospital, hot water is required at every time. So can't we recover that heat and make a hot water with that? It's possible, it's happening. Why can't we do on the residential building and other buildings also? So this is actually whatever the wastage we are doing, either energy, water, or the waste. If we do the recycled way some way, it has helped us a lot in the green building design. So we have seen when we do the projects for the green building certification, we get maximum point whenever we put these kind of a technologies in place on that.
Okay, so my next question is to Akshay. So when we speak about measuring performance, so how do you think or how important is it to develop a customized building performance evaluation for the Indian context? And what are the challenges associated with measuring performance?
Yeah, thanks for this question. Like I said, from back to my slide, the level one, the basic infrastructure is very important, and developing a customized benchmarking is also very important when the building is really wanting to be mature in its journey of addressing the sustainability imperatives around energy, water, waste quantification, and all of that. There are broadly three types in which a building's performance can be benchmarked. One is based on its own historical performance, which is considered the most accurate, where, based on the past year, what is the current year's performance, given, all other aspects related to occupancy, the weather conditions, and, if there are no major events or no major changes in the building design, how does the building operate year on year? So that can be figured out. Another second option is if I do not have a historical usage, then I can basically compare my building with a similar set of buildings in the same geography, in the same climate zone with a similar, occupancy profile. This is again, there are a lot of ifs and buts because buildings are very unique in the way they get operated and maintained, and they are also dependent on the way humans really interact with the buildings. So, but then there are studies in which can be conducted, or surveys which can be conducted to identify what is the energy performance index of a particular building in the same vicinity, and that can be compared to gauge whether the building's performance is in the right direction or not. The third way is by means of, let's say, by means of a large sample data that gets collected by either the government or such an agency, and the benchmarks are basically defined. Like in the case of India, Bureau of Energy Efficiency has kind of come up with the table of energy performance index for different building typologies, be it hotels or commercial buildings, or and so on and so forth. So looking at that number, I can get to see whether that number is above or below my building's performance, and that's how I get to know whether my building is operating optimally or not. Now, these three are by far the ways in which a building performance can be benchmarked. But then, if I have to really keep continuously improving based on my own performance, then I have to really have a very customized way of doing that. And that is basically enabled by having a more comprehensive, first thing, availability of the building performance data. And second thing is, if I have an analytics tool or my building management system is allowing me to do that.
Guys were talking about benchmarking and all that, but I am having trouble getting my clients to measure in the first place. So the resistance to metering is really strong in our country, is something which I feel that, especially if you take with respect to water metering, people just don't want to know. I'm coming from a city like Chennai, where either we don't have any water or we have too much water. There is no in between, to be honest. So where measuring the water consumption is becomes very important, but that somehow seems to be quite down on the list of priorities for a lot of people. So that's also because, say, if you take, say, an apartment complex or something, then everyone is looking at cost optimization. Why are you adding meters? I don't want this extra cost and all that. So pushing against that itself is quite a big task, is what I feel, when, because you use the word Indian context. So I just felt I wanted to add to that.
Okay, so my question to Abhishek. So when we speak of renewable energy, like what do you think are the policy barriers to the adoption of renewable energy? And how is this impacting green building certifications?
Yeah. So there has been a significant push in adoption of renewable energy by the Ministry of New and Renewable Energy as well as the central government, where there is incentives for rooftop solar for individual residents, but then those subsidies are currently limited for residential building and not being extended to commercial building. Apart from looking at subsidy and taking benefit of various government policies, there are other challenges in terms of net metering cap. So, for example, some states have a net metering cap of 500 kilometers. So, if the building has installed capacity of more than 500 kilometers, they cannot take a net metering or only they have supply up to 500 kilometers. The other issue is that there are no same policies across various states. So, in renewable energy, there are two options for any certification project. One is either they install renewable energy on site or they procure off-site renewable energy. So, there are open access friction, and then there are states which impose additional charges for open access, which becomes a hurdle uh, while sourcing renewable energy, and also timely sourcing it. Because when we look at the implication of certification, all of these aspects has to be completed within a particular set time frame. So that also becomes a challenge, where it has been seen that some of our projects we were able to secure the entire process of taking open access sourcing for renewable energy took around 3 to 4 years. So, in terms of certification, the project was not able to claim the applicable benefits or incentives available for those credit points specifically for it. One more challenge which we have faced is because there are import duties on solar panels. So, some cutting edge technologies like building integrated photovoltaic panels, they are extensively costly uh, to be imported and integrated into the building sector. So that is also one challenge which we faced in some of our projects.
Okay, thank you. Anybody else wants to share their thoughts uh, on this renewable energy?
Yeah,
Ideas?
there's a challenge with the adoption of renewable energy here in India. One of the thing is like the grid. So renewable is not just about, say, putting solar, putting wind, and but the grid also should support it. So there is a lot of transmission issues. There are problems with replacing transformers. And since electricity in our country is a state level thing, I feel that there are a lot of challenges, especially since in COP26 we announced we will put, I think, 200 gigawatt, if I'm not right, by 2030, we will reach that goal. To reach that goal, I feel that a lot of more of a policy level push is required, rather than more than market, and also development of indigenous technologies are also required. We cannot keep on depending on other countries for the fuel cells and all of those things. So that's what I feel. Couple of challenges as well.
Okay, great. So you mentioned about technology. So this question, I mean, I welcome anyone can take it up. So, how do you think technology is leveraging green building certifications in India and some major technologies like which are really being the game changers? So, if anyone can start,
I'd like to take this one.
sure.
With the current version for lead version 4.1, which is addressed by a technology platform, I think that is very easy to relate to and a game changer where buildings can report performance and get their performance assessed with respect to there is some analytics that goes on the back end, and you get to see how your building is really performing based on the past 12 months of data. Now, in order to enable this, there are multiple ways in which the data can be fed to the portal, and one of them is obviously integrating it with your building management system. So the building management system exports the data, and that gets imported on the portal, and you can see that kind of a real-time progress. Now, you see that the green building rating systems are also basically demanding this kind of a performance data, and based on that, they are evaluating and letting you know whether you are really optimally operating or not. And based on that, you can take targets for yourself and keep continuously monitoring and improving. So these kind of interventions are scalable, replicable across all building typologies, and by far being embraced by many of the previously certified projects as well. And this will continue to happen. Now people are really talking about going at across the portfolio level, because they have certain mandates to really kind of disclose all that data in the ESG reporting that they do. So in these things, these kind of technological upgrades are really helping. And by far, there are various platforms which can be used to quantify that data and then further export it to such a platform which is independently able to tell you.
So I just want to highlight,
Sure.
can you hear me, right? I want to
Yes.
highlight
Yeah,
related
yeah.
to the technology part, and it is game changer. I'm telling you because I'm working last 17 years. I have seen, and AI is something is going in every industry, and this industry, building industry, is also not too far. What I'm telling you, because today I have seen the people are making a product which can optimize, because we have the BMS system very popular everywhere. But there are the AI plugins in the BMS system now. Earlier problem is happening. A lot of people are not using the BMS properly. They have the data, but they don't have a time to analyze. They don't have a skill to analyze. And that's the reason the game changer come up for energy data, water data, waste data. If you do the proper energy saving, water saving, your data should be utilized through the AI. So you just click on it, which HU is not working properly, what problems I'm getting, you will get the result. So this is how the operational, whenever whoever the operational companies, whoever the like a company like CBRE, JLL, or these companies who are managing the properties, they get so much impact because of this. And of course your operational cost, because now every time the people is not only just paying for the system, in future or already it started in US and China, people are talking about performance contract. They will not talk about only just a contract to purchase anything. They will link with your contract with the performance of the system. If I'm purchasing a chiller, if I'm purchasing any big building item, that should be linked with the performance. And that is how the game changing is happening. So these technology we have to understand. We have to go in India also in futuristic with the energy performance contract work, and it will happen. So this is I have been seeing like startups are coming up. Earlier I have not seen any big startup in the air conditioning industry, but today I can see the 4 or 5 different startups. They are making $1 million company now to on this startup. So this is can be the game changer. So technology playing a very important role. Whatever we are handling, we are optimizing. It is very small, just doing this kind of work. But if you involve the technology, it can be multifold on it. And this is we have to follow. The data is the next oil of the country, next oil of the world. You need to understand how you can do data analytics in the building side as well.
Okay, so now my next question is How are ECBC and NBC sustainability provisions driving green building certifications in residential buildings in India?
I would just like to add by saying that these codes are really embedded already in the green building rating systems for new construction projects, and most of these buildings get designed based on the on these codes. For residential, there is Econivas Samhita, and for commercial buildings, there is ECBC. And an alternative code which gets used universally for commercial buildings is ASHRAE 90.1, which is considered equivalent to ECBC. I mean, there are definitely various versions that are coincidentally in use at the same time. But which version is being used also defines what is the level of stringency of the energy code. In all of this, both ECBC as well as ASHRAE continue to evolve every few years. The cycle is of 3 years for ASHRAE 90.1, and for ECBC it is about 10 years roughly. So in these codes now, whenever a new version comes, the stringency improves, the efficiency requirements also kind of get more stringent. And a trend that we are getting to see that all these codes are going in the direction of no compromise building envelope to begin with, followed by a little more focus on the metering and monitoring needs. When we say codes, these codes are further put into law in a particular state which gets adopted. So when this happens, then there are reporting requirements also. So a building which is compliant to ECBC at the design stage is supposed to basically submit its performance data every year to the government. I mean, there is a signature by the building owner onto this, and this is how the compliances are getting stringent. Right now, probably the government is busy getting these codes implemented, but over a period of time, as we move to the next phase of maturity, these will be definitely then seen. And then in Maharashtra, they have also discussed incentive and penalty mechanism. So if your building was basically supposed to operate in the range of, let's say, 2 lakh units per month, and if you are exceeding that, then there is a penalty. If you are reducing your energy from the mentioned number, then you may be eligible for incentives. So these kind of policy changes are also in the pipeline. Sooner or later, they will come. And these changes are already in place in cities like Singapore. We also get to see something happening in Dubai in the same lines, and in many parts of the US and Europe as well.
One more point I would like to add, because when we talk about codes and green buildings, codes are minimum to do,
Minimum
right?
performance, yes.
And green building certification compliances forces to exceed the performance required in a code. So that's one
Right.
difference between the certification requirement in correlation with various codes like ECBC, ASRE, or ENS. So
Right. In this, one more point is, even the green buildings ratings are now talking about two things at the same time. One is energy efficiency, and another is the source of energy from which you're feeding your building's energy demands. So if it is coming from a greener source like solar or any other renewable, then you basically get more points. And if your energy efficiency is higher, then you get another set of points. So this is by far lead is moving in that direction. But I'm very sure that other rating systems and even the code compliances will also follow this course over a period of time.
right, the code compliances are also getting stringent. So for example, the National Building Code is going to come up with a chapter on embodied carbon.
Embodied
So
carbon, yes.
that's a upgrade from what conventionally has been done. We're looking at how the market is moving. The code requirements are also, but yes,
Yes.
it takes time for new code to reflect the changes.
So we speak about green buildings and those buildings that are coming up new. So what about the existing buildings? Like, do you think retrofitting can move buildings into getting green building certifications, or how do we
Yeah.
do that?
So yes, a very right question. In my slide deck, I also mentioned that all buildings are existing buildings and they're supposed to perform. All these rating agencies, be it IGBC or GRIHA or LEED or even EDGE, they have a different, way of different versions of rating systems meant for existing buildings only. There we are not talking about the design elements or the site features and all of that. There it is more about implementation and monitoring your performance metrics, and then optimizing and implementing certain projects to improve the performance. All of this is also further enabled by deploying very comprehensive operations and maintenance practices on the floor, educating the operations and maintenance team, having certain policies at the building level with when it comes to things like renovation of the facility, that time how the waste gets handled, or use of certain chemicals within the building, be it for cleaning or for other purposes. And then there are other policies related to energy, how the utilities are basically operated and maintained. So by implementing these set of policies, or by having certain monitoring and measurement systems in place, and by having a certain calendarized way of putting certain things forth. Let's say, for example, every year at least once the indoor air quality testing should be done, and based on that test results, certain measures should be implemented in order to maintain the indoor air quality at a optimum. So these kind of things definitely are there, and many of these existing building rating programs also mandate the need for conducting a comprehensive energy audit for the building, which opens up lot many opportunities for either retrofit or replacement of equipment, or right sizing of equipment, or also triggers the direct need for measurement and verification related aspects. Now, in doing these things, when we conduct an energy audit, it also basically opens up into certain areas which were really not in place at the design stage or when the building was initially designed, but over a period of time, certain interior areas got changed, certain a number of occupants got changed, or certain equipments got added, and all of that. Because of that, the course correction also, it is the opportunity to investigate all of that and align things ahead. So that is how the existing building certification exercise begins, and it kind of addresses all these aspects related to energy, water, materials, indoor air quality, and others.
Great, thank you. Anybody else wants to add any of their insights to this question on retrofitting? Ashu or Kritika?
Yeah, I think Akshay has explained pretty well in the last 2 3 minutes. I heard that. So great. So yeah, but of course, in this entire procedure, same like ECBC for the new building, energy audits plays a very critical role in the existing building, because whenever you go in any existing building, there are the potential to save 20 to 25% energy saving can happen. If you go any government building, there is a 30 to 40% potential to save energy on it, because they are using the technology which is 10 years back. So right now I'm working with several projects like World Bank projects where we are doing energy audit for industries. So that is kind of a projects which we are doing in Rajasthan, in other state, and we have seen the potential in any MSME. There is a 24 by 7, those motors are running which are 15 years back they purchased, and MSME doesn't want to focus to change that. Same like in a building which we have seen, the laptop or the computers which they are using, that is around 150 160 wattage or 200 wattage. Now these days the very sleeking technology is coming up. So we have seen not only just on energy and HVAC on the lighting, we talk about the IT equipment load like data centers. There is a technology when earlier it was a PUE, we were taking 3, but today we are talking about 1.5 PUE because of the energy efficiency technology and the process loads are coming in that direction. All energy star rated, like B star rated products are coming. Motors is I5, so there are the chances to save lot of energy. But people has to understand right now what happening, that lot of people are asking towards renewable energy like solar, wind. Solar and wind gives you a 5 years payback. I'm just telling you as an energy engineer guy, 5 year is the payback for it. For energy efficiency, the payback is 2 to 3 year. So best business is energy efficiency in that way, because you are just saving in the wastage. You are not putting anything on it. So 2 years payback is far, far better than the 5 years payback. When the people or the financing people are getting understanding, that is the reason now the every bank is coming up with the energy efficiency loan. They understood the concept. This is the best way to sell. So it has become a very good business. If you have a money, don't put in your share market, put in your building energy efficiency, your payback will be 2 to 3 years. So that is something the people are now realizing.
So, another question that I wanted to ask, what do you think are the challenges to adoption of green building practices in India? One is like, as you as you said, there is resistance to change. The other one is the initial cost. Apart from these two, what do you think are the factors that are actually impeding this adoption?
In my experience, it is just
Again, it's an open question. Yeah, yeah.
so in my experience, I think it is just a not proper having knowledge, because we are creating myths. Sometimes what happens when we learn very few, we think that we know everything, but we don't know actually. So people having a myth that green building is expensive. People think the green building is the big buildings can go for the green building. People think that green building it will take more time to complete it. So these are the myths, and like people like us, Abhishek, Akshay, and Kritika, we are trying to break those myths that green building is not expensive. Like I give you an example of my own building. I constructed a building recently. It is a 25,000 square feet office, very small office. And that entire building is a net zero building. Whatever energy we are consuming, we are generating our own. And that possible in the small 25,000 square feet office also. So why can't we do with the 2.5 million, 3 million square feet building? We can do that. But small offices, the small houses can go green for sure. But the proper awareness is required. The technology is also not expensive. I'm telling you, I have done the calculation. Very soon I will publish my case study also in that way. The cost of the construction, when we talk about, actually it is reduced, because when I constructed own building earlier, it was normal people design on 150 square feet per ton. My building designed in the 350 square feet per ton. I reduced the 60% of initial cost of air conditioning because of the proper design. So it is less expensive actually, but still people having a myth that green building becomes more expensive on it. So this is something I feel the awareness is still required at every level.
And I'd like to what Ashu just said. This is very, very true. And the problem is also a little elsewhere. Our education system is not really updated with all of these aspects, and these concepts are yet to get deeply ingrained into the engineering and architecture education. Especially for bachelors as well. So I recently had a very good discussion just a couple of weeks ago with some of the professors who are having ASHRAE student branches in their respective colleges, and we all had gathered for planning one of the events. So when we started discussing, this topic got resurfaced that the engineering education and the architecture education in India really is up for overhaul, and these concepts around integrated design practices, and the architects should also know a little bit of engineering, and the engineers should also know a little bit of architecture, so that they get along very well with each other, and there are no difference of opinions on the design table. So these things come with a very evolved mindset. I mean, everyone would agree that after working about 10-15 years in this space of green buildings, we all have had chances, irrespective of whether we are engineers or architects. We all have had chances of working with all these important stakeholders who really help us design and build the buildings. But then the mindset evolution only happens when they have kind of experienced all of this themselves. Only then they are able to believe. Otherwise, they just want to stick to their old way of doing it, and that is a bit of a problem in today's world, where the expectations are really evolving very fast.
Right, Akshay. And I would also like to add, because typically as architects and engineers, we don't want to do things which are wrong. But I'll give you an example which currently we are facing in almost all parts of India, for the issue of urban flooding. Now, when we design, say, HVAC system with to specify that 150 square feet per ton of air conditioning, and he was able to manage it with 350 square feet per ton, which means that the conventional practice is to do over design. Same goes with structural design, where if a building is required to take a load of 400 kgs, a structural engineer will design it for say 300 or 350 tons. But when the same engineer is required to design for rainwater harvesting, he will under design. If a space receives 100 of rain, he will design for 25 of rain. And that's been happening throughout the country, right?
Yeah.
And this has been happening because wo chalta hai. People get approvals with that. And in our country, we have a tendency of doing whatever gets done with the minimum effort. So that is one of the major hurdles which I feel is the barrier between moving a conventional design to a environment friendly and sustainable.
And the same thought applies for the sizing of STP. The sizing of STP is usually done oversizing, where we are on the other hand wanting to implement water efficiency measures, and then towards the execution, then things kind of go after during the operations and maintenance phase. STP is oversized, and there is no kind of enough feed to it,
Load, yeah.
enough load to it. So, and that is definitely a design problem, and the designer needs to understand that he needs to really now move beyond thumb rules and really come to the ground and see how the design is being done, what all sustainability measures are being implemented, what are the goal statements that are coming from the client, the council, and the other side of the story. And that's how the at least having those design share meetings early stage. Everybody is equally busy, but wherever we've had these kind of design share meetings where we are able to really relay all these expectations, the client has really benefited immensely in terms of cost saving, time saving, effort saving, and a very good outcome in the project. But then these things are one in 10 is what I would like to say, and then we really need to really take a leap from here to making it mainstream.
And I want to add to the original question of what are the challenges that we face every day. I feel that we are also looking to popularize the green concepts a lot more. In fact, even now, I've been in this industry almost 15 years. Yesterday, I told someone I'm a green building consultant, and they said, what all plans will you supply for me? So that is, a kind of a popularization at the grassroots level is also required. Everybody should be asking questions like, what are we doing in terms of using the water, electricity? Even now, if you go to major IT offices, the temperature is kept very low. It's very cold in all those places. And people just like Abhishek ji was saying, this chalta hai kind of thing. They'll say, okay, I'll bring a jacket and I will sit. But they're not questioning, why is it this so cold? Why do I have to put up with this? And so I feel that we have to also work towards, maybe I would use the term glamorizing green concepts as well. We have to work towards it, making it look attractive, not just in terms of say money or something, but in terms of an achievable lifestyle or something to look forward to, that maybe the stars are doing or something like that, the celebrities are doing. Towards that also we need to be working so that these green building concepts are adopted and become more mainstream across the country.